Okay. Let's see. Let's see. All right, I think we are good to go. Yeah. All right. Hi everyone. I'm Francisco. I work on the Atelier Labs project, which is basically building open source high performance software for decentralized and financial machine learning. And in today's stream, actually, this is one that is going to be more well organized. I've been doing a couple of tests before, but I hope this one is a little bit more concise and compact as well, and hopefully to be very productive. So for today's stream, I'm working on this project which is called Atelier. And basically what this is a computational framework or engine, if you like, for market microstructure and high frequency modeling, and specifically to provide a way of generating synthetic simulations with data structures that are prevalent in financial markets from the microstructure perspective. And the more prevalent one is the limit order book. As well, but not yet quite stable, will be the other feature or capability, which is a historical market reconstruction or a market replay in a sense. And by that I am trying to aim towards two very kind of different types of approaches or types of discovery process related to quantitative modeling of financial markets. From one side is historical reproducibility in any granularity, and the other one is simulation, more or less. But in particular, I made the distinction of doing first a synthetic simulation, and that means from just a collection of models and techniques and considerations or algorithms, the simulation is created without any historical information. So that is useful for one, it's a stress test environment that is 100% controllable, in the sense of every single process is the output of a definition. The other benefit of doing a synthetic simulation is whenever the engine provides the synthetic version, then another process might be created apart from actually the Atelier project, which will be a calibration process, in the sense of whenever the history is available up to a certain level of granularity, then a calibration process will be benefited from the overall capacity of generating a wide range of results, and the way of inferring or performing reverse engineering, for example, of a particular state or series of states in the market is going to be available from a computational perspective, in the sense that capacity will be as if from historical values you have a granular description of what has happened, the history, no, the snapshots of the history. And in the other hand, you will be able to have an engine that generates any history. So by merging the two, you will be able to do what it is similar to generative adversarial networks, for example, which is you have the history and you have the generators of history. Then you can start a process of trying to generate a synthetic history that is very similar, increasingly similar across iterations to the actually observed history. And with that, in principle, you will be able to derive the parameters and the set, well, first the set of models and considerations, and then the parameters as the input to those models and considerations whenever the synthetic version of the market is close enough to the actual observation of the market. So that is going to be a very interesting outcome. We'll see how it evolves. So this stream is not the first one, as I just mentioned. I already have a couple of other ones that are related to this particular project, Atelier, and the other one, which is called Traderman. And also during those streams and offline, I've developed up to certain progress or capacity for this particular project, and that means things already exist. So let's take a look into those. So let's see. These are actually the references that I'm going to be using, but let's first take a look into the crates content. Now I've switched from a single project type of structure to a workspace type of structure in the Rust infrastructure, but I just forgot to include to move the README file, so I'll do that. That's why this is empty. Previous versions were janked because in order to prevent people using these, since there has been a lot of changes, especially from 4 to 5, the previous two versions, in terms of the structure actually. So it's not only that the early versions didn't have any or fewer features, but the structure has changed. So that is one particular thing to note. From now and on, I don't think the structure will be changing that much. But in any case, that's one thing that has happened, and I don't think it's going to be very consequential at this point of development because it's on the early stage and nobody's using that much of this, apart from a couple of people that I've been sharing this for kind of an auditing process. In terms of the documentation, there is some, although it's not perfect. I'll try to improve this increasingly towards the next iterations. But for now, what I can show is the general structure in the sense of the modules. For now, the data abstraction in terms of data structures and some of their implementations are contained within the data module. Metrics is one particular decision that I made in terms of, instead of creating the implementations within the data structure, I've just created the proposition of the data structure as a metric, or otherwise the metric as a data structure, and then to implement some of the, let's say, shared functionality is through a trait kind of interface. No, it's on the early stage still, but it's a stable working process so far. So I think that that's a good thing to have defined at the fundament at the foundation of the project, and then to later on build on top of that. So the metric, a particular metric, can be defined by anyone by extending the definition of a new struct that implements a particular trait, and then the data structure can be as well proposed if that comes into a benefit from somewhere else. So it's more modular in that sense. And the third module is related to the simulation capacity of the project, and in particular with the first data structure that is available, which is an order book, and within that definitions of an order and a level, which is kind of what composes the order book. And those three levels of granularity are actually one of the, let's say, differentiators of this project in comparison to all the other projects that are out there, either in Rust or any other programming language, because the order book based modeling or the microstructure approach for modeling and the programmatic way of doing that is not a new thing. It has been present in the past 20 to 30 years. So there's a lot of things out there. But I think the main proposition of have full granularity up to the level of order parameters and specifics within levels, and then levels within the sites of the order book is one value proposition. So yeah, I think for now it's kind of good as an overview. It's better to take a look into what is actually on the code, because there's a lot more there than the content that is documented. So let's see. Some of the things or the stuff I'm going to be doing might be a little bit trivial, but yeah, feel free to interact and see if you have a valuable comment, then go ahead. No, I'm trying to learn at the same time Vim, and this is Neo Vim, but Vim as a whole, or as an environment development. So maybe that might show from time to time, but just try to be a little patient on that. So this is the library definition. The project, as I mentioned it earlier, will be, actually it is already defined to support workspaces for a bigger kind of framework later on to be built. But for now, it's just the Atelier library. And in terms of examples, I have several ones. I might try to run a couple of them, but I think before going into that, I might as well take a look into the contents of the README. Yeah, there is not that much actually. But what I'm going to share, which has a lot more details in terms of what is going on for this stream, is the following. It turns out that for the Etera Labs initiative, I've created, let's say, projects which are also public. So with that, I can share the development process and the things I'm creating among contributors and things that other people is adding up to. And for this in particular, I have 3 projects that are kind of self-contained, and for now at least I'm mainly working on those, and for this one, the data streams, my friend Charlie is collaborating with this, and the intention of separating into projects the development is with the purpose of trying to disaggregate the changes at the level of functionality, but obviously within the same repository. So with that, we hope to keep collaborating and not interrupting kind of streams of development, no? So one particular thing that is on the works is to incorporate into the Atelier project another project which is Trolley, and that project is going to be providing a fast, efficient, parallelized and secure way of ingesting data from webhooks or, let's say, data streams coming from exchanges into one instantiation, let's say, of the Atelier project, and have the order book structure being used in order to collect updates of order books real-time, efficient and secure in that sense. So that is a lot of work, and that is on the side of from third-party data sources, incorporate such data updates into the data structures that the Atelier project provides. Now, in regards to the other projects, as the name suggests, are related to particular topics or dimensions or sources of functionality. The one that I'm going to be addressing for today's stream is the modeling one, because I'm going to add the functionality of, by the definition of a particular quantitative process, simulate the arrival and characteristics of the orders into the order book. So that goes into modeling, because the effect is for now just going to be shown as example tests for let's say a single order book or a stream of order book or a generation of order books, but as a small and shallow example. Because in the synthetic market generation project, the features that are meant to be contained within that are related to activity in terms of scaling the capacity of order books being generated. For example, at this particular stage, one of the things that is pending to develop is a parallelized way of generating order books within the existing definition of doing so, but with very different parameters and computing threads and so on. So that goes into the action of generating synthetic markets, not as much as defining the models that then later on generate synthetic markets. And the other one is repository artifacts, which is, I think what is missing there is improvements in documentation, support of LaTeX for the sake of mathematical completeness and specificity in terms of the models, like the one that I'm going to develop in this session. And this one I think is for now on hold. But yeah, so let's go into this one. Let's talk about this ticket I just created. No? So the context is that the existing capability of the Atelier project provides a definition of an order book in terms of a structure, and within that order book, limit orders can be created and stored according to the order book logic in terms of the matching engine that is the most classical one, which is the FIFO. Now, whenever such orders are generated, the characteristics of the arrival time of those orders for now is very simple, in the sense of it's either an equally spaced in time series of timestamps or a sampling process from a Poisson probability distribution in order to have that modeled a little bit more in discrete time and with kind of that logic behind, no? Of arrival times of something happening, which Poisson is the, say, standard for proposition for modeling that. Yet in the academic literature there is one particular approach for doing this that is prevalent, and that is to consider the arrival of orders in this particular case as a point process, meaning it's not just a definition of a discrete event, but as well a process that has other particularities that are of interest in regards to the application. And in the financial markets application, that means perhaps the time a set of orders will arrive has to do with events or triggers, and as well the distance between the orders might be highly correlated to the point of clusters of orders could be observed. So that's the logic behind it. The problem is that the Atelier library does not currently support other solutions rather than the sampling process from the Poisson distribution, which does not consider heterogeneity in terms of the arrival times for the orders, but the contrary, it considers the homogeneity in the sequence of that events to occur, because are equally distributed and are independent amongst each other, no? Thus, the need is to incorporate a model that is capable of providing the option for the scientist or the person that is modeling this to incorporate the clustering effect of the orders, and as well a way of definition, a way to define the intensity of the orders arriving, whether it's self-inflicted or exogenous effects are into play in that effect. Thus, or at least for making the solution for this particular need that comes after the problem definition is let's create what is called a Hawks process type of functionality. And let's start with the most basic definition for it, which basically means it's a linear combination of two factors. One is the base intensity, and the other one is the kernel, the computing kernel that outputs the corresponding values for the expected times of arrival or the instantiation of the orders arriving. And since the definition is a little bit, well, not a little bit, there is a formal definition for it, I've included the kernel part of it, but I think I'll expand this, maybe not in the documentation of the issue, because it's kind of that is just for reference, I guess, or perhaps I'll expand in there as well, but definitely in the documentation for the package, or I mean the package, the crate, no? And that is actually something very interesting, because the docs, the standard docs that are generated for Rust projects does not natively support straight off write straight without any type of modification full LaTeX specifications, and being those rendered in order for those to be visually present and rendered in the official documentations of the project. No, in order to have that, I have opened another ticket, but that is going to be developed after this one is completed, and of course after having the enough mathematical content in order to include there, so to find the balance between, yeah, there is the mathematics in there, but still the Rust documentation is about the Rust implementation, not as much as the theory of what is being implemented. But nevertheless, I think it's going to be very useful to have it there for people that works on quantitative finance all around the world. Okay, and well, in order to take this as completed, basically there needs to exist a way of calling the Hawks process in order to contribute into the simulation part of the arrival of the orders into the order book whenever the synthetic simulation is being conducted. So that would be some notion of completeness, as well as the usual stuff, which is a file or exist, maybe more than one, but definitely a test also exist. All right, so this is the documentation, this is the actual ticket, and the way of organizing this into public projects. As I mentioned it, these are the technical references, but I think I'll mention those later on. For now, what I would like to do is to show the basic functionality that is closely related to the thing that I'm going to be working on, and the overall structure of the project as well, at least to the present version. So let's start with the later, actually. Examples is no-brainer. These are just standalone examples. I'm trying to do one per overall capacity, although in the future this might be expanded or even reduced. In terms of the modules, there are three, as I mentioned it when we were reviewing documentation. data, metrics, and simulation. One particular consideration I'm making is, apart from this project supporting workspaces, the other one is the formatting. So as for now, this is not strongly enforced in terms of contributions, but later on I'll try to define every single rule for the roast format tool, and then a job is going to be created within the GitHub workflow definitions. So whenever somebody creates a pull request, that is going to be reviewed automatically by that job and reformatted following the definitions for the project. But for now, it's kind of not that important, but will be in the future. Yeah, contributions is on the works. Changelog, I think I'll update that within this within the definition between 0.5, which was the previous version, and I think either all the way up to 0.1, which will be the public stable release, let's say. But I haven't decided that yet. Perhaps I'll do that like that. Wait until the 0.1 to modify the changelog. Otherwise, he's going to have a lot of things. All right. In regards to the content that is the aim. Let's see. Yeah, this is the progress I've been making the past hours. And I think at this time we will review a little bit of the theory, especially the mathematical definitions, for this to be clear enough. And I think I'll use no more than 5 minutes for this, I guess. So let's take a look at this. This paper is going to be included into the documentation as a citation, and as well replicating some of this notation, because I find this very clear and generic enough in order to find similarities among other academic resources. So the definition that I took actually for the kernel, which is just another way of saying a computing component or a computing function for the purpose of generating an output, is what was this one, no? And this is the simplest form of kernel, because it's just a linear combination of two factors through a multiplication. One is alpha, which can be considered as a parameter to be optimized or explored, and the other one is the exponentiation up to a certain value, and that value is beta, which is also as well another parameter to be computed. And this for every step that is kind of the incremental simulation within all the n desired counting of simulations, or the the number of elements that are being counted. So this is for the univariate case, but if the multivariate case is, well, this is, this actually supports the multivariate case in the sense of the definition, but the full definition is this one, since it includes both the component of the kernel, which is kind of this one, and the other component, which is this one. So for the sake of definition, there is all of this is in detail in here, but has been derived from this one. So this notation actually is another way of expressing this other notation, and whenever these three are expressed, they mean the same, and it means there is a way of defining one case as a point process. I think it was up above, but I think I'll just speed up things a little bit. If we take this definition, the one here, what we need to implement is, this is a value, a parameter that is indexed for one particular counting process if we have n counting processes, or d counting processes in this case. So that parameter has the restriction has to be strictly increasing and positive, because we are trying to all the time generate sequentially ordered points in time. So that is one restriction which is captured by this property, which basically means whenever one defines a particular process, and that is within the boundaries of having every single new element is an incrementation of the previous one, and that is a strict rule, then that is this is the way of defining that in the sense of the definition. So for the multivariate case, every single counting process, or let's say every queue in the order book, is going to have the realization of such process. So if we define 3 levels of the order book being their orders being generated, then we can use this type of definition, no? So every queue is going to have its parameters, mu, alpha, and beta, and for within every queue, every instantiation or every new element that is simulated from the Hawks process is going to be referencing the first one. So that's why this comparison, algebraic comparison, or just subtraction really, is expressing. And before going into the code, I think I'll just want to, well, I think I already have that defined, which are the parameters. So mu is the baseline intensity, meaning there needs to be either explicit definition of what's the base, or that might be 0, no base at the beginning. That's a parameter, and that means the expected value of the next timestamp that marks the arrival of the next order. That is the baseline intensity. Now, the alpha parameter is the excitation factor, which in other way can be understood as how much that original event excites the following events. And the beta is the decay rate with which the diminishing of the presence of the orders is going to be observed. So how quickly the influence of the past order diminishes is defined or expressed by the beta parameter, no? And because of the mathematical definition of this being for now the kernel is the one that I use is this one. This means that alpha is directly related to this, so it's kind of an amplification factor, and beta is kind of the acceleration of the influence of the previous order as the base reference, no? Among the other base reference. So actually, before trying to do any estimation, what this particular development I'm trying to do here is going to be aiming is just for the definition, and then just pick some random numbers for the parameters, mu, alpha, and beta, and then just see that works. And that for the very basic case or definition of just a single counting process is just like we are trying to first implement the case of n equal to 1, which is kind of not that difficult, to be honest, in terms of the formula, because it's just a linear combination of factors and that's it. But nevertheless, I'm trying to do that in Rust from the very beginning, and at the same time with the theoretical definition. So let's see. I have my other notes here. Let's see, because I already had some progress on this. So I was working on the definition of the stroke of the Hawkes process, and yeah, for now it can include only this, because this is kind of the kernel in a way, not exactly because it is containing the mu factor, but for sure this can be thought as not the structure that is going to be containing the actual values in the response. It's just kind of the generator for that, and it's kind of the definition of it, not the instantiation and everything else. After that is going to be waiting. We are just starting with the definition. So that's one thing. Now, let's see. We have this new, then we have the compute For this, what we need to do is let's see. Let's see. Current intensity. This one should be an F64. And the implementation is going to be the derived from the formula above, which means we take mu, then we take alpha, and then I think how is it? First we do the beta multiplication times the t value, and is negative, so self beta times t, but t is not yet defined. Okay, but what is missing is the exponentiation, of course. I think it can be done like this. Let's try to be more simple. Yeah. All right. So for every t, then this is going to be applying. What is missing is the actual reference that made the whole purpose of self-exciting process, which is it needs to be some sort of comparison or difference between the previously existing value and the index of the following value. Those two need to be compared like this, no? So if j was equal to d, yeah, so this will be n, I mean 1, and it's equal to this one. Yeah, I think that's it in terms of the definition. But in terms of the implementation, this S needs to be an order timestamp already generated. So is is going to be either defined in the function signature or within the struct there is going to be historical, I mean the base or the reference value. I think I'll try this approach where I define this here and T is going to be the index to that indicates the progression of the orders being generated, and S is going to be the reference timestamp or the anchor timestamp. I might as well expand the names so to be more expressive of what is supposed to be there. So T anchor, I'm not convinced. And T anchor. Okay. All right. So this is the new. This is the compute. What else? What else should I be doing? This is the actual computation. So what is next is the actual generation for this. Let's use this one like this. Okay. T progression is see. 1, 2, 3. This is the next one. Of course. What? see this. Of course. Actually, I want to do this correction right away. I do not want to use floats, but unsign integer for timestamps. And I need to do the conversion, yeah. Oh, I see. I see. I think well, let's use just what is needed. In here, these timestamps later on will have to be converted to floats. Previously since they need to be in that format in order to function that compute. I was thinking something else at the same time I was talking. That's weird. Okay. So that's the intensity for a single compute. So lambda I, what it is exactly? It is called intensity, but I haven't defined very well or understood very well what actually means or represents a value of lambda. I think I have to read more. The number, it follows a Poisson distribution. Intensity. All right. So the interpretation for this is that let's see, the expected number of events let's try to derive this from an extreme case. So this is the anchor. Actually, I'm going to switch places because the notion of the anchor usually is on the left or the first value. So for this case, if the anchor has one value of timestamp and then the other one is far away, the rate should be lower because there is a lot of gap or space between the two. So the next one should be not that different from the first two. Okay, so what about actual timestamps right now? Let's see. Let's paste this one here. This is the anchor. And this, I'm going to add, if these were milliseconds, it's at 5 here. Okay. So the baseline intensity, decay rate, very fast decay. See a slower one. Okay. TM core, yeah. Relation. Instead of the 5, let's add a lot smaller difference. Interesting. Baseline, let's lower the baseline. Okay. So this is, I think I got it. These are seconds. these are seconds. Arrived 50. Oops. So there is a 50% chance that a new market, a new order is going to be arriving to the market at the next second. Okay. All right. So this is it. In terms of the implementation, it's very simple. What I'm going to do next is to have a break, but after that I'm going to add a little bit more documentation in regards to this functionality and a test for it as well. But yeah, this was a kind of a short one because I already had a couple of definitions and the framework and even a little bit of progress on the code as well. But yeah, stay tuned to see more development in this particular project. Okay.